So I'm a PhD student in Stockholm University in Sweden, and I will be presenting my talk titled Female brain size affects the assessment of male attractiveness during nature. So the huge variation that we observe in brain size across species have definitely important implications. Being the brain the center for behavior have important implications for variation in behavior across species, and from that follows that variations also in sexual behaviors and sexual selection relations with brain size. So in the literature we find examples that have studied this link between sexual selection and brain size. For instance, a comparative study across primates found a positive correlation between brain size and mating success across primate species. And also studies across bird species have found a correlation between brain size and the complexity of mating behavior that different birds like bowerbirds constructing their bowers, and manakins who have a very complex acrobatic display behavior are able to, so correlating with the brain size, how complex these behaviors are. So these studies have these comparative studies give us very interesting examples. However, ideally we want to complement these comparative studies with experimental evidence, and for that, in this project I'm using this tool that we have that my supervisor in Corral University in Glasgow and Alexander Corral have created these artificial selected lines for brain size in the guppy, and we can use. So these lines have been selected for now 5 generations, and they present up to 13% difference in the last data that we have collected in the 4 generations. So we can use this to test the link between sexual selection and brain size, right? In these lines, in previous studies, we have observed that large brain females outperform small brain females in a numerical test. So when we were looking at the difference in cognitive ability, and also in a very recent study that we have done in the 5th generations, the last one, we also have seen that large brain females outperform these small brain females in a reversal learning test. So we have this difference in cognitive ability between the large and the small brain lines of female guppies, and it's also a magnificent tool for testing this link between sexual selection and brain size, because as you might be aware, guppy is a very classic model for sexual selection studies, and female choice is a main driver of sexual selection in the species. And males present these multiple traits like coloration, conspicuous colorations, and also the tail size, body size. So multiple traits that females use to assess the quality of the male. So given this difference in condition that we have between the females, the female lines, and these collections, this study we assess, or we question whether brain size difference have implication for the assessment of attracting males in female guppies. In order to test this, what we did was take from a wild type population that we have in the lab. We took 60 males, which were young but sexually mature males that we put together with females, and know that we were performing sexual displays. And these males were from the same age, and they were size matched. And then we measured their colorations, and we took the 8 pairs. So 8 males with a more colorful and larger tails, and 8 males with a less colorful and smaller tails. And finally, between these 8 pairs, we have a 26% difference in total correction, 10% in orange coloration, and 27% in tail size. So we call these males attractive because these traits have been repeatedly been shown to be preferred by females in previous tests, in so many tests that have been done in this species already. Not because, well, that's why we call the attractive traits. Right? So then we test the preference for 36 virgin large red females and 36 small, also virgin small red females, and also we add 16 virgin from a wild type population, and we measure the preference towards an attractive and a non-attractive male in a classic dichotomous choice setup, where we measure the time that they spend in the different choice areas. And these are the results that we got. So in the y-axis, we have a value 1 will mean that the preference for a female spend all her time with an attractive male during the mate-choice test, while in a value -1 will mean that the female spends all her time with a non-attractive male. Right? And what we observe running a linear mixed model where we control for the pair of the effect of the different pairs and the effect of the different replicates of brain-selected lines that we have, is that the wild type and large brain females present a significantly higher preference than small brain females for the attractive males, which didn't present a significant preference for neither attractive or non-attractive males. So we wonder whether this difference that we find in the preference for attractive males in the females could be due for visual perception difference on how they assess these attractive traits. And since we couldn't ask the female guppies whether they see an 8 or a 3 in this image, we did it in two ways. We measure the physiological performance, and also we measure the expression of vision-related genes. So for the automotor response, what we did was using a typical response, physiological response that the guppies have, that when they absorb a rotational stimulus, they tend to move around to maintain the relative position, as you can see in the video. So what we did was to create a series of rotational stimulus with different contrasts of colors and present it to the females and measure their automotor response, which is called this physiological response that they have observed. And as you can see in the graph, we found when we present higher contrast, we do see that the females move more than in their basal response than when we present this stimulus without rotating, right? You see in the first panel. But when we decrease the saturation contrast between the color bands, then we don't see a different response, automotor response. And then to control that they didn't get tired during this test, we increased to the maximum saturation, and we saw that, again, they were performing this rotation more than they do it by the basal movement. What we don't see, again, using this linear mixed model approach, is a difference between the large brain and the small brain lines in their automotor response. Again, we also collect eye samples from this fish and measure the certain opsin expression, which are the light-sensitive proteins in the retina of the fish. And then, in a collaboration with Judith Mack and Natasha Blotz from University College of London, we measure the expression of these genes. And you don't have to go to the table. There is no difference in any of the genes that we measure. So, in summary, what we find is that the large and small brain female guppies differ in their ability to assess the male quality. And this difference is probably not driven by the ability of females to visually perceive the male attractiveness, since we don't see a difference in neither the physiological response and their option expression. I haven't shown you these results, but during this test, preference test, we found no difference in activity or the time spent that the different females spend in the male choice areas, which indicates that it's not likely that the difference in motivation by the different brain lines are showing us this difference in the preference, right? And so what we have left is that these differences are likely driven by difference in cognitive ability, given that we know that these females present this difference in cognitive ability, large and small brain females. And this might have very important implications for the maintenance of variation in sexual traits. And theoretical models of sexual selection usually assume this rational mate choice, like females will prefer their best options. However, we are seeing increasing literature in the opposite, both in very recent studies in fish, amphibians, and birds have some what we can call some irrational mate choice and some context dependent. When we include some decoy effects, we see that females are not preferring what they were supposed based on what they will be better for their fitness. And we know that ranking and assessment of prospective mates is an important factor underlying this variation in the maintenance of sexual traits. So even our results, it may be that variation, the huge variation that there is in brain size and cognitive abilities across species and within species could be such a mechanism in controlling this maintenance of variation in sexual traits. With that, I want to thank all co-authors in the study, Niklas Kolm, Alexander Michel, Wouter van der Weij, and Severin Michel from my home university, Stockholm University, and Judith Mack and Natasha Block from University College of London, and funding agents, and especially the funding agency that was giving me the travel grant to come here. Thank you very much.